Okay, in this video, we're going to be talking about complex numbers. Now, consider the number 5 plus 2i, because 5 is a real number and 2i is a pure imaginary number. They are not like terms and cannot be combined. So this type of number is called a complex number. So you have your real numbers, you have your imaginary numbers, and then you have the combination of the two, which is complex. Now, every number that you have ever dealt with then is a complex number. A complex number is the system of all these real numbers and imaginary numbers put together. So you might have real, you might have imaginary, or you might have a combination, but they're all complex numbers. The standard form of a complex number is a plus bi, where a is the real part, b is the imaginary part, bi. So therefore, adding and subtracting complex numbers, this is going to be super simple because all you're doing is using your basic methods that you learned back in Algebra 1. You're combining like terms. If there's a plus sign between them, the parentheses are really not necessary. And you're simply doing negative 11 and 9, which are like terms. That'd be negative 2. So you're adding the real parts. Now you're going to add the imaginary parts. Positive 3 and positive 2 would be a positive 5i, and you're finished. And as it says, the final answers must be in a plus bi form. So the a would be the real part, and then the imaginary part second, and we're good. So adding, you're going to add together your real parts, which would be 11. Add together a positive I and a negative 5i and gives you a negative 4i, and you're finished. Number 3, subtraction. Now with subtraction, you do have the extra step. Just like with polynomials, you got to distribute the negative. So negative 2 minus 6i. Then you do the same thing. 7 and negative 2 gives you 5. Negative 2 and negative 6 gives you negative 8i. Finished. Number 4, anytime you have a minus in front of parentheses, make sure you distribute it. So you have your 6i, the parentheses turned into negative 14 and a plus I. The plus in front of parentheses, let me try to write that I a little bit better. The plus in front of parentheses, we can simply drop those parentheses, so plus 5 minus 3i. Combine all your real parts first. Negative 14 and 5 would be a negative 9. You have 6i, 1i, and minus 3i gives you a positive 4i. So negative 9 plus 4i. Okay, next up, we're multiplying. We're going to multiply here on the first one, a pure imaginary by a complex number. Again, same principles are going to be used. Again, we're leaving our final answers in a plus bi form. 2i times 8, distributive property gives you 16i. 2i times negative 3i is a negative 6i squared. Reminder of the pattern, I to the first, I to the second, I to the third, I to the fourth. So anytime you have an I squared, you've got to replace it with negative 1. So this is now 16i and a negative 6 times a negative 1 for that I squared, which would be a 16i plus 6, which let's write our real part first, gives you 6 plus 16i. Done. Negative I times negative 2 on this one, distributive property would be a positive 2i. And negative I times a 10i would be a negative 10i squared. Anytime you have an I squared, again, we're going to replace it with a negative 1. And if you'll multiply that together first, we'll have it in the right form. Negative 10 times negative 1 is a positive 10. Then you just bring down your positive 2i, so 10 plus 2i. Number 7, we're multiplying a complex number times a complex number. We do so by distributive or FOIL. 7 times both. 7 times 4 is 28. 7 times negative I is negative 7i. I times both. I times 4, it gives you a positive 4i, and I times negative I is a negative I squared. Anytime you have an I squared, we replace it with negative 1, so you now have 28 minus 7i plus 4i minus negative 1, which is the same thing as plus 1. Combine your reals, 28 and 1 is 29. Combine your imaginaries, gives you negative 3i. Number 8, same thing, we are foiling or distributing. 2 times negative 5 gives me negative 10. 2 times negative 3i is negative 6i. Multiply negative 4i times both, that'd be a positive 20i and a positive 12i squared. Anytime you have an I squared, again, it is replaced with a negative 1 if you'd like to go ahead and do that. Combine your reals first, and I can go ahead and do this all in one step. A negative 10, and when you multiply this, you'll get a negative 12. That'll give you a negative 22. Combine your imaginaries next. That gives you a positive 14i, and that is your final answer. Number 9. We're squaring. Let's use our shortcut. Square the first. That'd be a 36. Multiply the 2 and double it. That'd be a minus 12 times 2 is 24i. And then square the last would be a positive 4i squared. However, this is, again, a negative 1. And if you multiply a positive 4 times a negative 1, what that actually does is just changes this to a negative 4. And you have now combined like terms. 36 minus 4 is 32 minus 24i. Number 10, we're going to FOIL the first one. 1 times both, 1 times 9, and 1 times 3i gives you 9 plus 3i. 7i times both gives you positive 63i plus a 21i squared. And then distribute the negative, be a negative 4 and a negative 2i. So now let's, again, you can just write it above it if you would like to. Plus 21i squared would be a positive 21 times a negative 1 would be a negative 21 right there. So now let's combine our like terms. Reals first, we have 9, negative 21, and negative 4. 9 minus 21 is negative 12, minus 4 is negative 16. We have 3 i's, 63 i's, and negative 2 i's. That would be 66 minus 2, which would be a 64 I. Okay, in the next part, we're doing complex conjugates. Two complex numbers of the form a plus bi and a minus bi are called conjugates. Complex conjugates because they are complex numbers. The product of two complex conjugates will always be a real number. Now, reminder to multiply conjugates. You don't have to go through the complete FOIL because the middle terms are going to cancel anyway. You can simply do 8 times 8 is 64, and then positive I times negative I would be negative I squared. So these are super easy to multiply together. So this would be 64 minus, replace I squared with negative 1. Minus minus is a plus, 64 and 1 is 65, and you do get a real number. 5 times 5, these are again complex conjugates. 5 times 5 is 25. Negative 4i and positive 4i is negative 16i squared. That'll be 25. Negative 16 times negative 1 will be a positive 16. 25 and 16 gives you 41. Number 13, dividing complex numbers. Watch out because I cannot be the denominator of a complex number. Reason for that is you cannot have a radical, or you're not supposed to leave radicals on the bottom of a fraction if it can be helped. If the denominator is a monomial, all you have to do is multiply top and bottom by I. If the denominator is a binomial, we're going to multiply top and bottom by the conjugate. So number 13, to do 10 divided by 2i, here's all you have to do. If you'll multiply top and bottom by I, it's going to take care of that I on the bottom. It's going to take care of that radical on the bottom. The top is now 10i. The bottom is 2i times I, which is 2i squared. And we know, again, that anytime you have an I squared, you can replace that with negative 1. So on bottom, you have 2 times negative 1, which is simply negative 2. And now you can divide those. Divide the real number by the real number. 10 divided by negative 2 is a negative 5. Leave the I, and you're done. You got rid of that I that was on bottom. Same thing here. I on the bottom, multiply top and bottom by that I. On top, you have 4i. On bottom, you have negative 9i squared. So that's going to be 4i over negative 9 times negative 1 is a positive 9. So you can leave it like that, or if you want to, you can put the I out next to it and write it as 4/9 I. Either one of these answers are fine. And again, the reason you can do that is that I is over 1, so therefore it would be the exact same thing. Number 15. Again, if the bottom is just a regular pure imaginary, multiply top and bottom by I. Now, since there's two terms on top, you do have to distribute. On top, you now have 28i minus 8i squared. On bottom, you have 4i squared. So let's replace all of our I squares with negative 1s. So now you have 28i plus 8. And on the bottom, you have 4 times negative 1, which is a negative 4. We can distribute this. Look, distributive property also applies to division. So we can divide both of these terms by negative 4. That looks like negative 4. 28 divided by negative 4 gives you a negative 7. Leave the I. 8 divided by negative 4 gives you a negative 2. And just to get it in the other form, let's flip-flop those. That'd be negative 2 minus 7i. And the next one, number 16. An I on bottom can be we can get rid of by multiplying top and bottom by that I. So the top is now negative 8i minus 2i squared. On bottom, you have 6i squared. Replace all your I squares with negative 1, so you have negative 8i. Negative 2 times negative 1 is a positive 2 on top. And on bottom, you have 6 times negative 1, which is a negative 6. We can split this using distributive property. You have negative 8i over negative 6 and a positive 2 over negative 6. Let's write that negative out front then. Clean that up. Negative divided by negative is a positive. You can reduce that. That is 4/3 I minus 2 divided by 6, which can be reduced as 1/3. Let's flip-flop them around. That'd be a negative 1/3 and a positive 4/3 I. Okay, the next ones, now you have binomials, I believe, on bottom. And a reminder that anytime you have a binomial on bottom, you multiply by the conjugate to get rid of it. If you were to try to multiply by just the I, it's a never-ending process of that I will not go away. So make sure you multiply by the conjugates. On top, you now have negative 10 minus 2i. On bottom, to multiply conjugates, very easy. Multiply 5 times 5 gives you 25, and multiply I times I gives you a negative I squared. So you have, let's flip-flop the top to write the i's first. Negative 2i minus 10. On bottom, you have 25 minus negative 1, which is 26. And again, you can split that. Negative 2i over 26 minus 10 over 26. That won't divide, but we can reduce it. That'd be a negative 2 over 26 reduces to a 1 and a 13, and you can put the I next to it. And then 10 over 26 divided by 2 gives you a 5 and a 13. There's your final answer. Number 18, binomial on bottom. To get rid of it, multiply by the conjugate, 6 minus 2i. So let's do whatever you do to the bottom, you have to do to the top of the fraction as well. That's the reason it's legal. 5i times 6 is a 30i. 5i times negative 2i is a negative 10i squared. On bottom, 6 times 6 is 36. 2i times negative 2i is negative 4i squared. So on top, you now have a 30i. Replace all the I squares with negative 1, so that'd be plus 10. On bottom, you have 36. Negative 4 times a negative 1 is a plus 4. 36 and 4 is 40. I'm going to switch the tops, 10 plus 30i, and then divide that by 40 to get my real part out front. So that's going to be division, distributive property of division, be 10 over 40 plus 30i over 40. 10 over 40 we can reduce to 1/4, and then 30 over 40 we can reduce to 3/4, and you can put the I next to it. Now working that problem just reminded me on that last one, those two should have been flip-flopped. That should have been negative 5/13 minus 1/13 I. They're both right, but you do want to put your real part first when you solve these. Next one, multiply by the conjugates. Conjugate of 2 plus I would be 2 minus I. Multiply the top and bottom by that exact same value. You will have to FOIL the top. 7 times 2 is 14. 7 times negative I is negative 7i. 3i times 2 is a positive 6i. 3i times I is a negative 3i squared. And you'll get into the habit of anytime you have an I squared, you can go ahead and change that sign to a positive 3. The bottom, 2 times 2 is 4. Since they're conjugates, you can then go to I times I squared, which is a negative I squared, which is negative negative 1. And as you multiply, as soon as you see that I squared, you can go ahead and replace it. So on top, let's do the real parts first. 14 and 3 is 17. Negative 7 and 6 gives you a negative 1i. On bottom, you have 5. And if you would like to go ahead and split it as you write it down, you can. And that will not reduce. So your final answer is 17/5 minus, I like it as 1/5 I. That way you have a number, the real part, or the real coefficient out in front of the I. It just looks better to me. And number 20, Multiply top and bottom by 2 plus 4i by the complex conjugate. So the top does have to be FOIL. 1 times 2 is 2. 1 times 4i is 4i. 8i times 2 is a 16i. And 8i times 4i is going to be positive 32i squared, which is a negative 1, which is just going to change that to a negative 32. The bottom, complex conjugates, 2 times 2 is 4. Negative 4i, positive 4i is a negative 16i squared. Instead of putting the I squared, times negative 1 would be simply a positive 16 now. Real parts, 2 minus 32 gives you a negative 30. 4i and 16i is a 20i. You're dividing by 4 plus 16, which is 20. Now let's split it. Negative 30 over 20 plus 20 over 20, leave the I. That's going to be, reduce that, that'd be negative 3 halves plus 1i.